Yesterday in the last lecture video, we talked about the first type of t-test. We said there are 3 types of t-tests, so we're going to go over homework problems we had on the single sample t-test. So if you look at the Whit and Whit book, we had, I think it was 13.5 and 13.7. And again, let's do that the easy way. The easy, the lazy way. So looking at 13.5, that says, the library system lends books for periods of 21 days. The policy is being evaluated in view of a possible new loan period. It could be longer or shorter than 21 days. So to aid in the decision making, we're going to look at records of periods actually where books were actually checked out. So just a random sample of 8, which again is not good design. That's not nearly enough, but keep in mind the Whit and Whit book was designed for you to crank these out by hand, but as I said, we're too lazy to do that. So I've got all these days books have been checked out, and I want to see how that compares with the 21. Now, other than the small sample size, can you think of anything wrong with this research design? And the small sample size is pretty bad anyway, but again, we still run the numbers. We want to see if people are checking out books longer or shorter than 21 days. So we're going to compare it with 21. Okay, comment was not allowing for renewals. Okay, maybe. I don't know how we count renewals. That's a good point. Choose one, what or the other. Okay, the question was made. We turned it. It's a 2-tell test as it's defined right now, longer or shorter. The question was asked and suggestion was made. Maybe it would be better to look at it as a 1-tell test, see if they're shorter than 21 or if they're longer than 21. Well, yeah, maybe that's a good possibility because we know that does change that critical region. How much is or where the rare region is, whether it's all in one place or if it's spread out over both left and right tails, maybe. My question about it is that it seems to me that however long the period you set forth in terms of policy, that's going to drive how long the books are checked out for. It's not just like you let people check out books and bring them back when they want to. You tell them they got to bring them back in 21 days. So to me, I'm not sure if this would tell you. It might tell you and this may be your suggestion. If people are keeping them less than 21 days, when they could keep them as long as 21 days, yeah, that might tell us something. It wouldn't tell us though if they want to keep them longer than 21 days. And this says longer or shorter. So as it is, it's a 2-tell test. So what we're going to do, see if I can get the right stuff on the screen for you. Put myself in the corner. I'm going to open up a blank SPSS document. You should be able to see that now. It just looks like a spreadsheet of rows and columns. And excuse me. And this is a single sample t-test. I've only got one sample. Didn't say the problem, but that's the only thing we can do with it right now. So I'm going to go to variable view. I'm going to name a variable. The only variable I have is I'll just call it days. So I'm going to type days in for my variable. Click off the cell so it defaults the rest of that row to whatever the automatic values are. We're not really going to mess with that any. We can change things if we want to, but in this particular problem we don't need to. So if I go back to data view, that day becomes a column heading. I'm going to put the days in the column underneath the heading of day. So the days we have are, there's 8 of them. So 21, 15, 12, 24, 20, 21, 13, and 16. Okay. So those are the number of days that we've actually had books checked out. So I want to compare this to see if it's longer or shorter than 21. So we're going to go to Analyze. We're going to come down to Compare Means. And it's a 1-sample t-test because we're comparing a sample or the sample mean, whatever it is, with a set value. So that's what I want to do. And that opens up my window with 2 boxes left, a box on the left and a box on the right. And then remember that the box on the left lists all the variables you have. We have only one at this time. The box to the right is a place for us to put the variables we want to talk about. It's just, and the only one we've got is the only one we've got. So I'm going to move. Question? Okay, have I got a number wrong? Okay. The last 7 should be, no, thank you for catching it. Okay, so 13 and 16. All right, thank you. Good catch. Okay. Now we're going to go to Analyze, Compare Means, one sample, move the days over, and then I don't want anything changed in options because it tells me the 0.05 level of significance, which corresponds with the 95% confidence interval, which is the default value here anyway. If it told me 0.01, I'd want to change this to 99. But I'm glad it says 95. That's what I want, so I'm going to continue. I've got one more thing I need to fill in. Remember what that is? The test value, and that's where we put the 21. That's the number we're going to compare whatever the mean is with. So I'm going to compare the mean with 21. So as soon as I click OK, I'm going to get an output window. So let's do that. OK, output window. Excuse me. Now cut some key things here. It tells me that my mean is 17.75 days. So they're checking out books a little less than 18. Now, if the time limit was longer than 21, would they check them out longer? I don't know. Maybe. That's why I think this is kind of a bad design. But the mean is 17.75. The standard deviation is 4.33 something. Here's my t-value, my degrees of freedom, and my significance. And I'm going to go ahead and talk about the mean difference and the confidence interval. I pretty much circled the whole page here. Don't much care about standard error right now, but everything else. At some point, I'm going to write this sentence, this part of the sentence. T, remember what goes in parentheses? The degrees of freedom, which is 7. We're told that. Where does 7 come from? Okay, the sample size is 8. Degrees of freedom is n minus 1, so 8 minus 1 is 7. So they can, this program is sophisticated enough to subtract 1. How nice. Okay, so T is 7 equals, now watch what I'm going to do or what I'm not going to do. 2.121. What did I not do? I didn't put the negative. Generally, we don't put the negative on t-values. There are some exceptions where I like it there. For example, and if we're doing a one-tail t-test with the lower tail critical, I think it's important if that t is negative or not. But in this case, it doesn't matter. We're just talking about the difference. So the t-value for 7 degrees of freedom is 2.121. My p-value equals 0.072. Now, here's the $1 million question, or at least the 95-cent question. Is our mean of 17.75 significantly different than 21? And the answer is a yes or no. It doesn't even depend. It's yes or no. Is our mean significantly different than the 21? The answer is, I see head shaking, no. Because the key thing in every one of these analyses is always going to be right there, the significance. That's the p-value. If the p-value is less than 0.05, in most cases, we may specify 0.1 or even 0.10. If the p-value is less than 0.05, we usually use, then yes, we have a significant difference. If it's not, we don't have a significant difference. So I am inclined to write, and this is just a good quirk. I like to write comma NS. So I have to wonder, well, if you're testing this 0.10 significance, I don't have to worry about that. I just write not significant so we don't miss that. Now I circled a couple of, this is the heart of it, and we'll talk about the APA write-ups because you've got APA write-ups due this week, or whenever we said they were due for the correlations, and by next week we're going to have an APA write-up due for a t-test. We're going to go over the other 2 types of t-tests tonight. So the heart of the APA write-up is what I've written in black at the top of my page. Now, what does that mean difference mean? Mean difference is negative 3.25. Okay, that's the difference between, right here, the mean and the test value. I'll call it TV for test value. Our mean is 3.25 points lower than the test value. Now let me stress something else I've mentioned before, and this is I've not been able to communicate this well. Maybe you can help me. If I look at the confidence interval, the confidence interval is from negative 0.687 to positive 0.37. That's the confidence interval for the difference. The confidence interval could be that our test value could be as much as, with 95% certainty, I'll say that word, our mean difference could be as much as 6.87 points lower, or it could be as much as 0.3735 higher. Now, what key number is captured within that confidence interval? 0. That means the mean difference might be 0. And if the difference is 0, there's not a significant difference. That's why whether 0 is in the confidence interval or not corresponds to whether we have significance or not. Let me say that again. If our p-value, I'll say it different ways. If our p-value is less than 0.05 here for the significance, you can see, I think you can see me moving my little pen around. If this p-value is less than 0.05, then 0 will not be in the confidence interval. It means the difference is likely to not be 0. If the p-value is over 0.05, 0 is going to be in the confidence interval. You may want to just kind of write that down and pray over it later. But I just want to point out the leak. Now, we're going to see in the APA write-up in a little bit, after we go through a couple more different kinds of t-tests, that we're going to see the APA write-up reports all these things I mentioned, except I don't think we talk about the mean difference, but we also do report the confidence interval. You don't have to go back and you don't have to go back and say, because 0 is or isn't in there. You don't have to say that. I'm just saying it is consistent with the other things we find out from other places. There's a lot of, as I've said before, there's a lot of duplicate information here. You just have to kind of know what to look at. The key thing is what I circled in red. And that's going to be true for every analysis. It was true when we first saw the idea of significance level. It was true when we talked about correlations the first time. Is that SIG number less than 0.05? If it is, it's significant. That also corresponds to rejected the null hypothesis that it's not significant. So back to my double negatives again, but I'm going to try to not talk much about those double negatives. So the answer is that no, people are not checking out books significantly less than or significantly different than 21 days. Again, I have questions about the research design, but these are the data that we work with. Any questions, thoughts about this particular problem? Okay. Let's go to homework number 13.7. Let me get rid of some of this stuff. And let me open up another blank SPSS file. And there it is. And the scenario here is that we've got differences in temperature for the last, 10 years? So a 1 means 1 degree temperature higher than previous. A 0.7 means 7 higher than the previous, the long term. So whatever year the first one was, that was a degree higher than whatever the overall long-term average is. And then the next year is 0.7, 7/10 of a degree over whatever the long-term average is. So those are our data. So I'm going to put those in here, and those are just, I'm just going to call them something like temperature differences, TEMP, DIF, and be reminded that you can't use spaces here. It'll yell at you. In mostly nice ways, but if you try to use a space, it'll say, oh, you've done something illegal or whatever they say. I don't like to do anything illegal. You get in trouble over that. So I'm just going to say temp diff. And then I'm going to click Data View, so that becomes a column heading. And I'm going to put those 10 numbers underneath that. And they are 1.7. And watch me, because we well know I can mess this up. Whoops, I already messed it up. 0.7, I said. 0.7, 0.9. Hold on. 1.1, 1, and 1. Okay. So those are our difference in temperature for a 10-year period of time. How much difference that year's average temperature was over the long-term average temperature. So we are going to, we've got a one sample. This is not quite as obvious. Question was, we would, yes, that previous problem, you would retain the null hypothesis. You would not reject it. You're correct. Okay, I'm still going to go to analyze, and then I'm going to compare means, and it's still a one sample t-test. Temperature difference is our only variable. What interval are we? What level of alpha level are we talking about? Level of significance. Can you see where it says so? Okay, this, well, the other side of that coin. Yeah. Okay, so we're going to look at a 0.01. It doesn't tell us 0.0, but it refers to the 99% confidence interval. So 0.01 is our level of significance, which means when we go to options, I don't like that default of 95. I want that default to be 99. So once I have the 99% confidence interval selected there, I have to ask, what is my test value? This is less obvious. The question is the temperature of the Earth getting warmer? What would represent not getting warmer? What number? What change would represent not getting warmer? Would not be the mean. What would represent not getting warmer than the long-term average? What change would there be? What would the change be? If it's not changing, what would the change be? Hey, that was put pretty brilliantly. 0. 0 means no change. So our test value is 0. Now, is this a one-tail test or a two-tail test? It's 1 because the question is it getting warmer? So we have to remember something in a minute as soon as I click this OK button and get my output window, which I'm going to do right now, OK, and output window. So what I found here is, okay, here's my mean, here's my standard deviation, here's my t-value, my degrees of freedom, my significant level, and all the other confidence interval, all that stuff. So I'm going to write somewhere, let me write this up before I interpret it. T for 9 degrees of freedom. Where does 9 come from? Because I had 10 different numbers here, or 10 years I'm looking at. That t-value is 22.02. Is that one I wrote over it? And my p-value, it's a little tricky and it's not. If you forget to do something, it doesn't matter, because this is a two-tail test. It says so somewhere. I'll get that off there. Anyway, it's under that double-click thing. What do you do to turn a two-tail test into a one-tail test in terms of the p-value? You divide it by 2, but 0 divided by 2 is still 0. Now, you can't say p is equal to 0, because there's always a chance you're being wrong. Normally we put p equal whatever the number I'm pointing to here is. But you can't say p equals 0 because there's not a 0% chance of being wrong. It's just they only have 3 decimal places to show us what's significant. And in terms of 3 places, where it's not 0, I can say p is less than 0.001. If you get 0 for the significance, don't say P is 0. Say P is less than 0.001. Now that means we're testing this, remember, at the 0.01 level of significance. Is there significance at the 0.01 level? Again, keep in mind, the key thing, and I'll do it the same way as the last example, is right there, which is also right here. So, is there a significant difference? The answer is yes, because my p-value is less than my alpha level. In this case, some number less than 0.001 is less than 0.01. So there's a significant difference. Specifically, the temperature is indeed getting warmer, at least for these data. And I say at least then because you can have hundreds of years of just kind of changes in the curve of the average temperature, but which comes to my disclaimer. Okay, for these data, yes, the Earth is warmer than the overall average for however many years we kept up with this stuff. Does that prove global warming? Okay, comment was made that looks like evidence that the Earth is getting warmer, but then I'll paraphrase what you said, but not necessarily for a certain reason. It can be getting warmer for a number of reasons. So again, keep in mind that this kind of research, I use that dirty word on purpose, the word prove. This kind of research doesn't prove anything. It demonstrates that there's likely to be a difference, but it doesn't indicate any kind of causation for that accounts for that difference. Yes, it's different, but we can't say why. Don't know why. I just can tell that it's different. To determine that something is a cause, you have to do some things like you have to have randomization and random assignments, experimental and control groups and all that stuff for true or pure experimental research, and we can't do that with our kind of, because you just can't do that with students or in education in general. You can't have you can't split days randomly. You're going to be warmer and you're going to be not. You know, you can't do that. You can't split it and say you're going to be controlled, you're going to be experimental. There's no, in this case, there's no treatment at all. It's just a matter of what describes it. So yes, there's evidence that the Earth is warmer, as you said, but there's not necessarily evidence, far be it from proof, that that's why the Earth is getting warmer. Any other questions, thoughts, comments about that? No, the question was, do we put an S? No, don't put anything. Just leave it like this. Just put an NS if it's not significant. And you don't, again, that's just me. I've seen a few people do it. It kind of clarifies things in my mind, but nobody's going to zap you if you don't. If I'm editing your dissertation, I might insert it, but it's not wrong to leave it out. So if it's not significant, I put an NS because, again, I don't know. If I get a p-value, if I get a p-value here of 0.03, but I'm testing at the 0.01 level, I would put NS to indicate, yeah, that's 0.03, but it's not small enough for what our test value or what our alpha level is. Any other questions, comments, thoughts about this or these problems? So we have some working knowledge of single sample, or sometimes they're called one sample t-tests. Are we all reasonably equally unhappy? It's my job. Okay. I can get rid of this.